Okay, so this is week 2. Again, we are in Stats XL10. Okay, and so if you missed it last week, if you were not here last week, the class website is this. And I just want to encourage, those of you who are sitting in the back row there, okay, I encourage you just come to the front area, okay, just because I think it will enhance your your learning experience, for real. You're allowed to sit wherever you want. There's no laws here, but I encourage you to sit up front, and I think it's better, okay. There have been studies that show that classroom seating is associated with higher and lower grades. Not necessarily a cause and effect relationship, but something is going on there. So anyway, you're allowed to move now if you want. You don't. For those of you guys in the back there, okay. Or just ignore what I just said. That's fine. So here we go. And so this is the class website. I know some of you guys missed last week, so I'm just going to go through this very quickly. So as not to... oh, it's asking me to log in. Give me a second here. Go. Good. Okay, great. Okay, we'll see. Here we go. Or not. Okay. Well, if the internet were to be working, it would load up. And on the class website, I have. Here we go. Last week's lecture videos. So you would, under 2015 Summer XL10, choose lecture videos. And my goodness, our connection is slow. Well, anyway, the page is loading. You can. The lecture videos, when that page loads, you can view last week's lecture in its entirety. Okay, it's been recorded and you can follow along. And this is in case you've missed class or you need to review some of the content that maybe didn't quite make sense the first time around. So you can go to the class website and watch lecture videos. And the homework, last week's homework assignment, is posted here under Homework 01. So if you missed last week or you just joined the class, I strongly encourage you to watch this. Part 1 goes over the course policies and what I expect of you and everything that you need to know. We're not going to do that again because most of you were here last week. And so I don't need to bore you twice already, at least with that content. I might bore you with statistics today, but I don't think it's boring. So anyway, okay. Any questions, Steph? Okay, great. Well then, we will move on, and today we're going to finish up a little bit of Chapter 2 and get into Chapter 3's stuff. So today during the quiz. A few of you did not bring a calculator, okay? Fortunately, you had neighbors that either lent you a calculator or, you had to forego using a calculator. Make sure you bring a calculator to class each week. Many of you went out and purchased a calculator, and that's great, and others of you already have a an adequate calculator, and that's also good. But you will need a calculator for the class, so make sure you have one. And you'll definitely need it for next week's quiz. Okay, so today, let's wrap up Chapter 2, which talks about representing, our data with pictures. Okay, so this is okay. I'm gonna have to position this mic. It just doesn't do a very good job picking up the audio this way. Okay, so I'll hold it this way. Now, is it too loud? Yes, it's okay. All right, so we want to represent our data with pictures. And so last week, when we got into Chapter 2, we talked about which type of variable, numeric or categorical variables. So last week we talked about categorical variables, and what were the tools that we used to picture or display categorical variables? There were two types of graphs. We had bar charts and pie charts, okay? So last week we looked at categorical variables, and we used bar charts or bar graphs and pie charts. And one thing about bar charts was that the arrangement of the bars is arbitrary, okay? And we talked about picturing variation, and we had summary tables for categorical variables. Do you remember what those were called? You saw one on your quiz today. Yep. Frequency tables, yes, thank you. We had frequency tables, and if you had two categorical variables, it was called a two-way table. Is that, I'm hoping. Okay, so we use bar charts and pie charts, and then also just to summarize summary tables, we had frequency tables, and we had two-way tables if we had two categorical variables. Okay, so keep in mind everything here this is for categorical data. Okay, and so this week we are going to look at numeric variables. Okay, we're going to look at some ways to display numeric variables, and then we will also look at ways to summarize numeric data. Okay, so we're going to take data. A data set, what is a data set? Okay, yeah, data set is our raw data, and how are we getting our raw data? Yeah. From a sample, exactly, okay. And why are we dealing with a sample? The population is too big, exactly, okay. So the population is too big to observe directly, so we draw a sample, and when we draw a sample and observe it, that serves as our data set, okay. And we might observe different features of the sample. They might be categorical variables, they might be numeric variables, we might look at them both. Okay, but again, just so we keep track of where we are in the big picture of things, Statistics is all about trying to make conclusions from limited data because we can't study the population directly. Okay, the population is too big. We're drawing samples. And so the beginning part of our class, last week and this week, we're going to talk about taking a look at samples and being able to describe what we see in a sample. So last week we talked very briefly about being able to describe data if you had categorical data in your sample. You can summarize, rather than saying, you know, Joe is male and Sally is female and John is male, etc., etc., etc. You can say, in my sample of 100 people, 52 are men and 48 are women. Okay, and that's one way to summarize your categorical data. If we're talking about a numeric variable, we would have to summarize the data a little bit differently, and that's what we're going to cover today. I'm going to need like a pop filter here. Okay, so numeric data variables. We're going to talk about graphs to summarize them. And so our first one is, so we'll talk about graphs to display numeric data. Okay, and always when I say numeric data, we're talking about numeric data from a sample, also known as a data set. Okay, and we have the dot plot. We have the histogram. And we have the box plot. So how do we display numeric data? Okay. So when you think of numeric data, you have to think of your underlying raw data table, where you have one row for every subject. Okay. And if you think about that, every subject has a row, and let's say you were gathering information on height, okay? Then every single person in that data set, if you had 100 people in your data set, you would have 100 different measurements for height, okay? And we want to be able to summarize that. Or if you have a small data set with only 10 points, 10 people in it, you would still have 10 measurements of height. Okay? And these are numeric things, so we're not going to be counting. Oops. We do want to save. Give me a second here. Next month is July. Look at that. Tomorrow is July, actually. Independence Day this weekend. Go America. Yeah. Do we have any international students here with us? Have you celebrated, have you had Independence Day in America before? Oh, okay, so it's not that exciting. But you're international? No. Okay. All right. Well, I hope you and do something fun this weekend. Enjoy some good grilling and fireworks and whatever American things you want to do. The red, white, and blue. Shoot some guns, maybe. Not necessarily. No. Not so much. Okay. All right. In a safe manner, of course. Okay. Anyway. Let's talk about a dot plot. Okay, so in a dot plot, every single subject in your data set is represented with a dot. Okay? So let's say, for example, we surveyed students in the class, and we said, okay, so we have a name. So this is our raw data table, and we just asked, how old are you? Okay? So, let's say we asked Joe. Joe is 21 years old, and Jane is 24 years old, and Bob is 22, and Ken is 22. I don't know. Okay, so I'm just making up data here, okay? So let's say, my classroom only had 4 students. So my dot plot would then represent all 4 of my students, each one with a dot, okay? And so because it's a numeric variable, I always have to have a number line to show where our data lies, okay? So I'm going to draw a number line. I'm going to have 20, 21, 22, 23, 24, etc., etc., etc. Okay, and so each person, so Joe gets represented with a dot at 21, Jane gets represented with a dot at 24, and Bob and Ken each get represented with a dot at 22. Okay, is that all right? Okay, and so in your textbook, on page 40, and also, well, I guess it depends which version of the textbook you have, we have pictures of dot plots, okay? And you can imagine, if you had lots of data points, you would have lots of little dots to show up in your dot plot here, okay? Is this okay? All right, so, if we surveyed every single person in this room, I think there's 32 of you, okay? How many rows would I have in my data table? 32 rows, okay, and how many dots would I have in my dot plot? 32, okay, so that was an easy question. Okay, all right, so it's very important, you must have a number line, okay? A number line to show the values of each dot. Okay, so histograms are very closely related to dot plots, except rather than having dots show up, you're going to have a bar representing how many data points that bar represents, okay? So I'll say like a dot plot, but without dots. Okay, so I've written it down, and it looks like you guys are copying that. It says, like a dot plot, but without the dots. It uses bars instead, and the height of each bar represents how many subjects have that value. Okay, so if I want to use the exact same very simple data set with only 4 people, I'm going to first have a bar at 21, and there's okay, and so our histogram would look like this. Okay, and this is a very simple histogram. We have a bar at 21 that is 1 unit high to represent that there's one subject or one person with an age of 21. And you have a bar that has 2 units, that's 2 units high to represent there are 2 subjects at the age of 22. And I know the bar goes from 22 to 23, and it seems a little odd, but that's just kind of the convention where values, starting at 21, this bar represents values starting at 21 and going up to basically 21.999, but not including 22. And that's just the convention for how it goes, but I know it might feel a little odd at first. Okay, so all I've done is we've taken basically the same information that's in this table and we've represented it with bars here. Okay, and this thing is called what? A histogram. Okay, how is this different from a bar chart? Does anyone want to say?
Bar charts have gaps in between.
Okay, so bar charts have gaps in between, or there's no space in the histogram. That's one thing to note.
Oh, and also, I think, never mind. The other one that begins with a P, it goes in order from like smallest to largest.
Oh, Pareto. Okay, so with a bar chart, yeah, you want to say something?
With a bar chart, wouldn't it sort of be flipped? So like the age would be on the other axis?
No, not necessarily. You can have a histogram that goes sideways as well, but yes. Okay, so here, maybe I should just give you the answer here. So with a histogram, the order of the axis here matters, okay? You have to go 20, 21, 22, 23, 24, 25. You have to, it's a number line. You can't willy-nilly change the order of the numbers, okay? Otherwise everything falls apart. So the numbers have a set order. You can't alter that. And with a bar chart, we said the order arrangement of the bars was arbitrary. If you wanted to put males as the first column and females as the second column, that was fine. If you wanted to switch them around and put females as the first column and males as the second column, also fine. It doesn't matter. If you want to arrange them in increasing order or decreasing order or alphabetical order, the arrangement of the bars in a bar chart is arbitrary. It does not matter. With histograms, you don't have that luxury. You have to put them in order of the numeric order. You have to put people who are aged 21 over here, people who are aged 22 over here, people who are aged 23 over here. And it doesn't matter if you have a lot or a few, you've got to respect the order of the numbers. So with a histogram, you can't rearrange the bars. You have a question?
With the dot plot, can you rearrange?
You cannot rearrange them either. Okay? With numeric variables, you've got to respect the fact that they're numbers, and 23 is a number that's bigger than 22. Okay? Question?
Why didn't you connect 23 and 24?
Because there are no people. So what goes here would be people who are aged 23, right? And in my data set of only 4 people, I have nobody who's aged 23. Okay, so basically, I have 0 people. Bars that are this high represent 1 person. Bars that are this high represent 2 people. Oops, and if there was a bar this high, it would represent 3 people. Okay? Is that okay? another thing with a histogram is you can group, you can do what we call binning of values. You can, let's say we asked 500 people, how old are you? Okay? And let's say, you know, it was across America, so it's not like college students, but you're going to have people who are old and people who are young. And if there were a lot of people, if we did, you know, it might not give us what we want to have a bar for everybody who's 21, and a bar for everyone who's 22, and a bar for everyone who's 23, and so on. Maybe it would be easier for us if we grouped people together and we said, this bar represents everyone in their 20s. This bar represents everyone in their 30s. This bar represents everyone in their 40s, okay? And we can do that with a histogram. Or maybe if you don't want to do that, you can say this bar represents everyone 20 to 24, and this one goes 25 to 29, and this one goes 30 to 34, or, you know, however you want to do it, okay? We can do that with a histogram. So let's try this out. Okay, so we'll do histograms with bins. Okay, so let's say this is our data set. And we're gathering ages here. Oh, shoot. Don't write all these. Okay, so let's say these are the values that we have. Okay, how many people do we have listed here? Let me just count them. 1, 2, 3, 4, 5, 6, 7, 8. Well, I don't know. Okay, there's a bunch of people. Okay, so we're going to turn this into a histogram with bins. So I'm going to create what we call a frequency table of our bins, okay? And so my first bin I'm going to say is going to be 20 through 24. So that's 5 ages represented there, okay? 20, 21, 22, 23, 24, 25. And coincidentally, I have 5 people aged between ages 20 and 24. Okay, so these 5 people go there. And then I'll create a bin for 25, 26, 27, 28, and 29. And I'm going to create another bin, 30 through 34, 35 through 39, 40 through 44, 45 through 49. And we're going to count how many are in each of these bins. So I have 1, 2, 3, 4, 5, 6 people in that bin. 30 to 34, I have 3. From between 35 and 39, I have 2. 40 to 44, I have 1. And 45 through 49, I have 1. So my counts are going to be 5, 6, 3, 2, 1, and 1. Is going from the data set to our frequency table of bins okay with everybody? Any question or confusion here? Yes?
30 through 34, but then there's no 34 on the data set?
Mm-hmm. That's correct. So we're asking, in your data set, how many people are between the ages of 30 and 34? Okay? Does it matter that there's not a person that's 34? No, it doesn't matter. Because the question is, How many people are between 30 and 34? There's 3 people, okay? We're not angry that there was nobody who was actually 34 years old. That's okay. All right. Yes, other question.
So like when we make these bins, is 4 the number we're always supposed to go by? Or
So this is actually a bin of 5, right? Okay. No, it's arbitrary. Okay, that's up to you. I chose 5 probably because we have 5 fingers on our hand, and but you know, bin width is arbitrary, but you should be consistent. You should not have one bin has 3 numbers in it and another bin that has 7. Okay, you got to have. If you're going to choose the bin width of 5, you should have all bins represent 5 numbers each. Okay, and what I mean by 5 numbers, you know, we've got 20, 21, 22, 23, 24. There's 5 numbers represented, or the width of my bin is 5. Okay, is that okay? All right, and so we're going to make a histogram. What goes across the bottom here? A number line. Okay, and so the convention again is you just do the number that starts the bin. So we're going to go 20, 20, oops, 20, 25, 30, 35, 40, 45, and 50. Technically there's another bin. The 45 to 49 bin ends at 50. The vertical axis shows our count. 1, 2, 3, 4, 5, 6, 7. So I'll just number these 0, 2, 4, 6, 8. And this is our histogram of ages. Okay, so I'm going to go ahead and just draw this. My first bar Okay, and so here I drew the histogram. The first bar has a height of 5 to represent the 5 people between ages 20 and 25. The next bar has a height of 6 to represent the 6 people who are between the ages of 25 and 29. Okay, so I just want to make sure creating the histogram is okay with everybody. Okay? Any questions on this? So I'm going to just make up a histogram here. So this is just a crudely drawn histogram here. Okay, so maybe we asked we asked several people aged, we asked some 28-year-old women, how many children do you have? Okay, and so we're so by the way, this bar has a height of 4 and this bar has a height of 7, and these are heights of 2, 2, 1, and 1, if there's any ambiguity here. Okay, so here's a few questions. How many people did we survey? So don't shout out your answers, okay? But see if you can answer these questions, okay? So write down on your paper. How many people did we survey? Okay, again, we surveyed several 28-year-old women, okay? And ask, what was the most common response? How many have no kids? And how many kids does the woman with the most kids have? So all of these questions should be simple to answer. And actually, so I know a lot of you guys are furiously copying these down, but you can write all of this down later, okay? Right now I want you to look at those questions and think of your answers, okay? And we'll go over these, okay? And then after we do that, then you can copy all of these questions and stuff down, okay? So the first one, how many people did we survey? So everybody look at the histogram. Don't shout out an answer, but think of this, okay? And again, these bars represent how many people in case, because it's kind of scribbly. So how many people did we survey? Okay, do we have an answer for that one? Yeah, what do we have? 17 people, right? Because every person in our survey is represented in this thing, and this shows that we had 2 people here and 7 people here, so we had 9, and then we have another 4 for 13, 2 more makes 15, and then 16 and 17. So how many people did we survey? 17. Is that clear to everyone? Okay. All right, what was, so again, don't shout out your answer, but what was the most common response? The most common response. Okay, now, what would that answer be? The most common response is 1. How many kids do you have? I have 1 child. Okay? And how many people said I have 1 kid? 7 women said I have 1 kid. Okay? How many women have no kids? 2. Okay? Can we see that? So I want to just make sure the answers to these questions are both okay. So I'll put the answer here. So how many people did we survey? 17. What was the most common response? 1 child. How many have no kids? 2 women. So far, so good? Okay, and then the last one. Don't shout out your answer. How many kids does the woman with the most kids have? Don't shout it out, but think of it. Okay, go ahead. How many kids does the woman with the most kids have? 7. Okay, so this one woman over here, she has 7 children, and there's just one woman with 7 children, but she has 7. That's what we have, okay? And I just made up this data, so who knows, okay? So can we read the histogram okay? The one child. Okay, the most common response is represented by the tallest bar. Okay, so the tallest bar is this one right here. Okay, the one that says 7. Okay, and this bar corresponds to what? What number? It corresponds to the 1. Okay, and so that means, because we're asking how many kids do you have, so the response is 1. So this is the number of kids. These are the responses. And over here we have the count. So we have 7 women who responded with, I have 1 kid.
The last question, how many kids does the woman with the most kids have?
Mm-hmm.
How did you see that?
Okay, so these are the responses, right? So we had one woman who said she had 4 kids. Do we have any women who said they have 5 kids? No. Any women who said they had 6 kids? No. We did have one woman who says she had 7 kids, and that's represented by this little bar here. Anybody with 8 kids? No. Okay, so the largest response we got was 7. And so the woman that has the most number of kids has 7 kids. Does that clear things up? Okay.
Yes.
Okay, good. So that's a histogram. Okay, and we've got to be able to read a histogram, understand how we create it, but then you probably won't be doing a lot of histogram creation yourself by hand, but I think understanding how the histogram is created helps us to then look at a histogram and answer related questions like this. Okay, can I go to the next slide? Okay. So we also want to talk about, sometimes the mic gets really loud. We want to talk about the shape of our distributions. Okay, so over here I've got a histogram, and we can kind of, this is, quote, a representative curve. Okay, so we can say, rather than having to draw out each bar, we can say, well, this histogram is represented by this curve. Okay, is that fair? Okay. And we would call the shape of this thing to be skewed right. So both of these things, this is known as the shape, is skewed right. All right, what does it mean to be skewed right? So what is the most common value? Okay. Are the most common values over here, or the most common values down over here? Down over here, right? And these, on the number line, are these large values or low values over numbers over here? Low, right? Because the number line always starts with small numbers over here, right? And as the number line goes over this way, these are high or large values. Okay, so this means that the most common values are what? Are on the lower side. Can we see that? The most common values are on the lower side. Okay, and you don't really have any lower than kind of this bulk over here. But we have some people on the high side. But are there lots of people on the high side? No, a few, okay? There's a few people on the high side, but there's not, but these bars are short, representing that there's only one or two people, very few people, okay? A few people on the high side. Okay, and this curve represents the exact same thing. So whatever we're talking about on the histogram, we can say the same thing. Most common values are on the low side over here, few values on the high side over here. Okay, and so this means is that we have people who have high values over here and very few, a lot of people down here, and then nobody who is even lower than this. Okay, and so this represents a numeric distribution. Okay, so think in your head, can you think of any numeric variable that might be skewed right? Yeah, what do you think?
Somebody's height.
Height, I would argue, is not skewed right, but rather symmetric, and we'll talk about that. Skewed right would be something like income, okay? Most people, their income, annual income, probably between $30,000 and $100,000 per year, okay? That's going to be most people. Are there people making $300,000 a year, $500,000 a year, $1 million a year? Yes. Are there lots of people compared to the rest? No. Okay, so you have people. So if this is like 30,000 and this is like 100,000, okay, then, you know, and 0 is over here, okay, you know, this is only like maybe 250,000, okay, but you know, we have people making a lot of money, but not a lot, not too many people making a ton of money, okay? Whereas the bulk, the majority of people are going to be making, you know, between like 30 and 100,000 a year, okay? And so, you know, over here, if this is somebody who's making 250,000 a year, okay, that's 150,000 more than right here. Let's say the center, you know, can we have anybody making 250,000 less than whatever this middle range? Let's say the middle range is 100, and that's not true. That's way higher than the middle range. Middle range is probably closer to 60,000. But yeah, so if somebody's making 250,000 more than what, quote, the middle is, 250,000 less than that would take me down to what, a negative 150,000 or negative 200,000, something around there, okay? Can anyone have an annual wage of negative $200,000? No, okay? You cannot go to work and be paid negative money. It doesn't work that way. So, so this is skewed right, okay? We have, so income is skewed right. We have a few people with very high values compared to everybody else. Most people are kind of on the lower end in terms of the grand scheme of things, and you're not going to have anybody much lower than that, okay? Okay, that's skewed right. What would a graph shaped like this be called? Skew left. This means most people score what, or have values that are low or high? High, and we have a few people who are low, okay? Do we have anybody higher than the high? No. Okay, skewed left. So this is skewed left, skewed right. And this would be symmetric. Okay? So most people are what? High or low or what? In the middle. Most people are in the middle. Do we have people who are high? Yes, but not a lot. Do we have people who are low? Yes, but not a lot. And we have just about as many people who are high as we do people who are low. Okay? So this means most in the middle. Okay? Some high, some low. Okay? About same number of high as we have low. Okay, and that's what it means to be symmetric. So I would say height, human height, would be symmetric. Okay? Most people are average height. So if, let's isolate, let's talk about one gender at a time. So in the United States, the average height is around 5'9", 5'10", okay? And most people are within a few inches of that. So I would say the most men are going to be between 5'7" and 6'1", okay? That's going to cover a large portion, okay? And you have some people who are taller than that, okay? So if the average is, say, 5'10", 6 inches above average would be 6'4". You have some people who are 6'4", not a lot, but you do have some people who are 6'4". And if you go 6 inches below the average of 5'10", that would take you to 5'4", okay? And you also have some people who are 5'4", not a lot, but you know, regarding men in the United States, not a lot, but you do have about some. And you have more or less about the same number of people who are 6'4" as you do people who are 5'4", okay? And maybe your personal experience says a little bit otherwise, but that's probably because you are hanging out with people who share a similar, whatever, similar background or things like that. And so that's going to kind of skew or make bias the types of people you encounter. But overall, you're going to have about as many really tall people as you have really short people, whereas most people are kind of somewhere in the middle. And the same applies for women, but just with different numbers. Is that okay? Questions about representing the shape? Okay. So another thing to mention when we talk about shape, so we have things with one peak, and these are known as the shape we describe as unimodal. Okay, and if you have two peaks, we say it's bimodal, and anything more than that, we just say multimodal. Okay, you could say trimodal, but we generally just say multimodal. So what does it mean to be two-peaked, bimodal? Yeah.
Just kind of no in between.
I wouldn't say that there's no in-between. In this picture here, we do have an in-between. It just means that there's some values over here that are very common and some values down here that are very common, okay? And whereas values in between are less common. Maybe there might be none, okay? But just less, okay? And so, again, what kind of variable are we dealing with, categorical or numeric? Numeric variable, right? And so you just imagine a number line here, okay? Okay, and so whatever numbers we have, we're saying values that are down on this side are very common. Values that are high over here are also very common. Values in between, less common, okay? So for example, we might see a distribution like this, okay? So this is where you have almost no in between, okay? Values in the middle, it's almost touching the axis, meaning there's hardly anyone in the middle here, okay? So common, common, and in the middle, rare, because it's almost zero here, okay? So this is a numeric variable. Can you guys think of anything, any numeric variable that would look like this? 2 peaks. Very little in the middle. What do you think?
To death rate?
Birth to death rate? And what do you mean by that?
How many people are being
Rather alive or you're dead.
Okay, so alive or dead, whether you're alive or dead is a categorical variable. Okay, so that does not apply. Okay, these are numeric variables. Okay, all right. So there's all humans produce testosterone. Okay, and we could take a blood sample, and we can do some blood work, or we can have you spit in a cup, and we can measure how much testosterone your body produces. Okay, and it's measured in some like milligrams per deciliter or something. Okay, something like that. Okay. And so guys produce testosterone, women produce testosterone. And if we surveyed a whole bunch of people and we had them spit in cups, or we drew their blood and we measured how much testosterone they produced, we're probably going to see a bimodal distribution. Okay? This peak over here kind of represents the distribution for men. Okay? There's probably an average amount of testosterone that males produce. Some men produce more testosterone than other men. Other men produce less testosterone than other men. Okay, but kind of most men will be within this range. Okay, and then you look at women. Women also produce testosterone, but by and large less than men. Okay, and so this will be kind of the average amount of testosterone that a woman produces. Some women produce more testosterone than other women. Other women produce less testosterone than others. Okay, but the majority of women will produce testosterone in this range. Okay, and you don't really have a whole lot of people over here. Okay, a value here would be either a man with very low testosterone compared to his peers, or this would be a woman with very high testosterone compared to her peers. Okay, but overall this would be you don't have a whole lot of people here. Okay, does that make sense? Does that work for you guys? Okay, so an example would be testosterone level. Okay, measured, scientifically. Okay, so it's important to remember that we are talking about numeric variables here. Okay, and categorical variables cannot be represented with a histogram. How are categorical variables represented? Bar charts or pie charts. Okay. But we don't really like pie charts. We like bar charts better. More. We like them more. Okay. Yes, question?
So, the bimodal was
No. It's one numeric variable, okay? I was just giving an example where you might witness that, okay? But not necessarily, okay? It could be anything where you have one numeric variable and you end up getting 2 values that are common, okay? Or something like that. Yeah.
Does that last histogram have a name where
The
the
mul-
2 sides are common and then there's one varied in the middle?
Yeah, bimodal is
Oh.
the shape.
Oh,
Yeah.
never mind.
Is that what you're asking? Or
You mean pretty much, yeah.
yeah.
Just
Yeah, to have kind of this 2 peak thing, this is known as bimodal. Okay? All right. Okay, so let's now we're going to move into chapter 3. So you got some questions on chapter 2 based on all of these things that I presented. And now we're going to go into chapter 3. Oh, why don't we take a short break here? It's a little after 8:30, so we'll say 10 minutes, come back at 8:50. I'm going to start at 8:50.